Today we're going to talk about adding, subtracting, multiplying, and division properties of equality. And then we are going to start our process for solving equations using these properties. Now, an equation is a statement that indicates two quantities are equal. A solution to an equation is a value for the variable that makes the equation true, which means if you come up with an answer or a solution and you plug it back into the original problem and it makes the left sides and the right sides equal to each other, then it is a solution. If you plug it in and it does not make the left side and the right side equal to each other, it's not a solution. But I would caution you to double check, because a lot of times people come up with the correct answer, but when they plug it back in, substitute the value back into the original problem, they do not perform the order of operations correctly. So it gives them the idea that their answer is wrong when in actuality their answer is correct. So be very careful with the checking. So if you notice in this example, that's the equation. They're telling me that 3 is the solution. So basically they're telling me that the value for y is 3. And then they substitute 3 in for y, and they make sure that the left and the right side balance. So they make sure that all of this does in fact equal to 11 by applying the order of operations. That's where most students mess up, is they apply the order of operations in the wrong order. So be very, very careful. The first two problems are simply asking us to determine if the given value is a solution to the problem. So what they want us to do is they want us to take -5 in the first example and plug it in for x and see if the left sides and the right sides balance. If they do, then -5 is a solution. If they do not, then -5 is not a solution. So when I clean up, I made my substitution. I put -5 in for x. When I apply the order of operations, I would multiply before I would subtract. Since -20 does not equal to 10, then no, -5 is not a solution to this problem. In the second example, they want us to take 4 and plug it in for x. So 3 times 4 minus 5 hopefully will give us 7. Order of operations, I need to clean up the left side. So that would be 12 minus 5, and that does equal to 7. So since the left side and the right side balanced when I plugged in 4, then 4 is my solution. Now, the definition of a linear equation in one variable says let a, b, and c be real numbers where a is not 0. Because if a is 0, 0 times anything becomes 0, and that knocks your variable out of this problem. So we do want an a value, but the b and c values do not have to be there. They can be 0, okay? This is normally what you're dealing with, one variable. A linear equation is one variable, and one variable is also called a first-degree equation, because the variable only has a power of 1. It does not have an x squared or an x to the third. Its exponent is an understood 1. So when you are doing the addition property for equations, and you're doing the subtraction property for equality, this tells me that if I have a left side and a right side that are set equal, I can add the same thing to both sides, or if need be, I could subtract the same number from both sides in order to solve the problem. So we're going to do just some basic addition and subtraction properties for solving equations. In example number 3, it says solve the equation. So what I'm going to do is I'm going to isolate x. And the way I'm going to do that is that -7 has to go to the other side. Well, the only way I can get rid of a -7 is to add the opposite of that. So if I say x minus 7 equals to 15, and I add 7 to both sides, I get x. A -7 and a +7 will cancel each other. And then 15 plus 7 gives me 22. Now, when I check my answer, 22 minus 7 should equal to 15, and it does. So I know that 22 is the correct answer for x in this particular problem. In my second example, I have x plus 1/8 equals to negative 3/4. I need to move the 1/8 to the other side, and I'm going to add the opposite of 1/8. So I'm basically going to subtract 1/8. So I'm going to subtract 1/8 from both sides. That leaves me with x. The positive 1/8 and the negative 1/8 will cancel. Now I need to do a little bit of math because I have to add negative 3/4 and negative 1/8. I need a common denominator, which would be 8. So that would be negative 6/8 plus negative 1/8, and that gives me negative 7/8. Now, before I say that's my answer, I'm going to plug it back in, and that means negative 7. I'm checking my answer by plugging my answer back in for x. So negative 7 plus 1/8 equals to negative 3/4. Well, they've got a common denominator, so that would be negative 6/8, and that does reduce to negative 3/4. So I would type in negative 7/8 as my answer. Now, they may want you to write it in solution notation, which means the braces, not parentheses, not brackets. So they may just want you to put your answer in the braces. When you use braces, that indicates that every number that you put inside the brace is a solution to the problem that you are currently working. Now, in number 5, it does have things a little bit backwards, but the point is you still have to make the left side and the right side equal. So I'm going to subtract 2.8. So on the left side, I get negative 1.1, and the 2.8s and the negative 2.8 on the right cancel. So my answer, I believe, is negative 1.1. When I check it, 1.7 equals to negative 1.1 plus 2.8, and that is true. When you add negative 1.1 and 2.8, you do get 1.7. So that is my answer, and you can put it in braces. It may or may not ask you to, but just in case, you know that the braces mean that every number you put in those braces would be a solution to your problem. Now, in the second set of examples, 6 and 7, we have a little more work to do. We're going to combine like terms first, and then we're going to move stuff. So in example 6, I have two x values on the left, so I'm going to condense those by adding them together. So negative 7 plus x, when you take negative 43 and add 44 to it, you get 1x. On the right side, I can go ahead and say 19 minus 3 because they are also like terms, and that gives me 16. Now, at this point, I can add 7 to both sides because I want to get x by itself. So a negative 7 and a positive 7 cancel, and 16 plus 7 is 23. If you check your answer, you will find that 23 is the correct solution. In number 7, on the left-hand side, I can condense that to negative 2. On the right-hand side, I have two sets of like terms. I have 4x and negative 3x. If you add those together, it gives you x. And then I can combine negative 8 and 9 and get positive 1. At this point, I would subtract the opposite of 1 to get it away from x. So 1 and negative 1 will cancel. So I end up with negative 3 equals to x. If you plug that back into your problem, the left and the right sides should balance. Now, as far as the multiplication and division and properties of equality or equations go, if I need to I can take an equation, A equals B, left side equals right side, and I can multiply both sides by anything that I want. Same thing with division. If I have A equals B, then I can divide both sides by the same thing. Now, the second property is the one that we use the most. We don't use the multiplication property as much as we use the division, but I do have a few examples of that multiplication property, and I'll show you what I'm talking about when we get there. Now, this is the most common method for solving equations using the division property. I have 9 times x equals to 45. So in order to move 9 away from x, I have to undo multiplication, which means I'm going to divide both sides by 9. The 9's cancel. 9 divided by 9 is 1, and 45 divided by 9 is 5. So my solution would be 5. Here, I divide both sides by -7 because that's -7 times m, and to undo division or multiplication, you divide. -7 divided by -7 is a 1, so that is m. 98 divided by -7 is -14, a positive divided by a negative. So my outcome is -14. In the last example, I need to divide both sides by the number attached to the variable, not the number on the left, but the number that is multiplied times the variable, that coefficient number. So I'm going to divide both sides by the coefficient. When I do that, I get 23 on the left, and 1.5 and 1.5 will simplify down to 1x. So 23 is my answer for number 10. Now, I told you just a minute ago that I would show you how you could use the multiplication property of equalities to solve equations. Now, you do not run across this one as much as you do the division property, the 3 examples that we just did, but you will run across moments where you need to multiply both sides by a number. So what we're going to do, if you notice in number 11 and number 12, both of them have a fraction with a number in the bottom, not a variable, but a number. If there were a variable in the bottom, it's totally different. It's a totally different chapter. So right now, we're only concerned with numbers in our denominator. So since 4 is in my denominator, and this problem reads y divided by 4 equals to 16. So to undo division, you need to multiply. So I'm going to multiply both sides by the denominator I want to get rid of. So I'm going to multiply both sides by 4. Now on the left-hand side, the 4's will cancel and leaves me with y. And 16 times 4 is 64. And that would be my final answer. In number 12, since it is a negative, I do not want negative z as an answer. I want positive z. So not only am I going to multiply by 3, I'm going to multiply by -3, because a negative times a negative will produce a positive. If I multiply the left by -3, I have to multiply the right by -3. So negative times negative is positive, and the 3's will cancel. 120 times -3 is -360. So my answer is -360. Now, we're going to kind of do the division or the multiplication property again. This one is a little bit different because this time we're going to multiply by the reciprocal. If you notice, I don't have x over 5 this time. I have a fraction times my variable in both 13 and 14. So what I'm going to do is I'm going to take that fraction coefficient and I'm going to flip it. So I'm going to multiply both sides by 5 over 2. When I do that, on the left-hand side, the 5 over 2 and the 2/5 will cancel. 2 goes into 2 once, 5 goes into 5 once. So I end up with x. Now over here, I have to do the same thing. So if I put 150 over 1, 2 goes into 150 75 times, and 75 times 5 is 375. So my final answer for number 13 is 375. In number 14, I am going to flip the coefficient. So I'm going to multiply both sides by negative 4/3. The reason I'm going to multiply by negative 4/3 is because a negative times a negative is a positive. So if I do that on the left, I have to multiply by -3 or negative 4/3 on the right. So negative times negative is positive. The 4's cancel, the 3's cancel. A negative times a negative on the right-hand side is a positive. 3 goes into 9 3 times. So that would be 12/5. So 12/5 is my answer for number 14. So those are 4 different examples of how you can use the multiplication property for equations. Now, for the last few examples, we are going to write an algebra expression and then we are going to solve the problem. So in these 2 examples, I have the sum of what? The sum of -10 and a number is 20. So the sum of this number and that number equals 20. The word is always represents the equal sign. So anytime you see is, that represents where your equation should go. Your equal sign should go. So in this particular problem, I will add 10 to both sides. So x equals to 30. In number 16, the quotient, that is a division problem. The quotient of what? X and -10. The quotient of x and -10 is 20. So this time I'm going to use the multiplication property. I'm going to multiply both sides by that denominator, which is -10. A negative times a negative becomes positive, and 20 times -10 is -200. So my solution is -200. Forgot to put my solution set up here. Apologize for that. Number 17, the difference of this number and this number is 20. So the difference, a subtraction problem, the difference of a number and -10 is 20. All right. I can change this to add the opposite, and then I would subtract 10 from both sides to get an outcome of 10. So my final answer would be 10. And then the last example in this particular set, the product of -10 and a number is 20. The product of -10 and a number is 20. So the product means to multiply -10 and a number and set it equal to 20. So I'm going to divide both sides by -10, and that gives me x equals to -2. So my final outcome is -2. If you have any questions about using these 4 properties, addition, subtraction, multiplication, and division for equations, please make sure you ask during class time.